Let's do an example where I have a rational on one side of the inequality. So same as the polynomial, I want to just factor both the numerator and the denominator this time. So that's going to factor into x plus 1 times x plus 1 on top, and x plus 4, x minus 4 on the bottom. And I'm going to set that equal to greater than or equal to 0. And now I want to be thinking about the function p of x is equal to all of that I just factored. And I want to be thinking about when p of x is greater than 0 and when p of x is less than 0. And to think about that, I'm going to use a sign chart again. And now I want to mark all the values that make p of x 0 or that make p of x undefined, because those are the only values where you'll be able to switch from positive to negative. So the values that make p of x 0 are when the numerator is equal to 0. So when x plus 1 times x plus 1 is equal to 0, that only happens at -1. So I'm going to plot that one. Now I also want to know when the denominator is equal to 0. X plus 4 times x minus 4 is equal to 0. That's going to happen at -4 and +4. So now I'm going to look at each of these sections and decide, is p of x negative or positive in that section by plugging in a point. So let's start here. P of -5. I don't even care about what the actual values are. I just want to know it's going to be positive or negative. So if I plug in -5 to x plus 1, I'll get a negative times a negative over a negative times a negative. So all 4 of these factors are going to be negative. And so 4 negatives is going to end up with a positive. So my function is positive there. Let's move to this section. If I plugged in p of -2, I'm going to get a negative times a negative on the numerator, and then a positive times a negative on the denominator. So 3 negatives and 1 positive, that's going to end up with a negative because I have an odd number of negatives. Plug in 0. If I plug in 0, I'm going to have a positive on top times a positive on top over a positive times a negative. And again, I'm going to have a negative here because I only have 1 negative here. And then do my final section. I'll plug in p of 5, and I'll have a positive times a positive over a positive times a positive. So all of those positives are going to end up giving me a positive. So I've made my sign chart, and now I just need to decide which intervals I'm looking for. So the question is asking for all of the places where this rational function is greater than 0. So I'm going to look at my sign chart, see what sections have positives, and write them out in interval notation. So anywhere from -infinity to -4, and I'm using a bracket because this is a greater than or equals to sign, is positive. And then anywhere from +4 to infinity is also positive. So this would be my final answer.